Okay, today we start chapter 4. It's about the motion in space or in three dimension. Last chapter, in chapter 2, we discussed about the motion in one dimension, 1D. So, and we learn the quantities as a distance, displacement, speed, average speed, instantaneous speed is same sample, and also velocity instantaneous and average speed as velocity as a factor. Then acceleration instantaneous and average acceleration. And we know that how to find these quantities by equations. Today we discussed these quantities in three dimensions. We can describe it how we can find it in three dimensions. So if I have a point, this point, for example, here, in space, that means in three dimensions, or I can draw it easily for you. So that is y, x, z, and we know from the factor, the unit factor, x with I hat, z with k hat, y with j hat. So if I have this point here for any object or particle, so I cannot describe this point with x only, with y only, because there is also a point for z direction. So how I can describe it in space? First, I use it as a polar coordinates. If I want this point, so just mention about it as polar coordinate. What is the polar coordinates? We can describe the polar coordinate by the magnitude and direction. So that means I describe this point here by using a polar direction r, for example this point 1, so that is r1, and we can point it this point by the magnitude and the direction of this point. So that is the first step. So described it with polar coordinate. Then if I want to describe this position specifically in Cartesian, what I can say, so this point 1, so P1 or 1, I can describe it with R1. Then in Cartesian it means x1 in I, y1 in j, z1 in k. So that is the point 1. If this object moves to, for example, to here, to this point as a point 2, same two rules. First polar, second Cartesian, x, y, z. So first for point 2, what I can do, describe it by polar coordinate. So that is r2, pointed to the point with Cartesian, then described it with polar, and described it by Cartesian x2. Why x2? Because point 2. If it's p, so xp, x, y, 2, z, 2. So that is the points. If I want to find the distance, for example, this object move look like this, so I can add it all this distance from the first to the end. But in factors we use displacement. What's the mean of displacement? It is the shortest path from between the points, So what it means? It means delta R. What is the mean of delta R? R2 minus R1. So that is, I draw it with another color. So that is delta R, the shortest path between the 2 points, point 1 and point 2. So now we go to this figure and describe the point. So for example, if I have a point A to point B, I have an object. This object moves from point A as 1, then to the final point P, the second point. So how I can describe it? I described it first by mention to the point with R coordinates, then I described it in Cartesian coordinate. Same for point 1, I do same for point 2. So first polar, second Cartesian. If I have a third point, so I do the same, x3, y3, z3, x3 in I hat, y3 in j hat, yz3 in k hat. So that is the important things here in this case. But here we know in dimension, because it is a factor, the factor moves in space, so R as a position factor. So I explain it in Arabic. لوصف حركة جسيم يتحرك في الفضاء أي ثلاثي الأبعاد، فأولا يحدد بالإحداثيات القطبية، تشير إلى النقطة بإحداث قطبي. ما معنى الإحداث القطبي؟ هو الإحداثي الذي يهتم ب ما معنى الإحداث القطبي؟ هو الإحداثي الذي يهتم بالمقدار والاتجاه، فتشير إلى النقطة مقدارا واتجاها، ثم بعد ذلك يتم تحديدها بالإحداثيات الديكارتية باستخدام الإكس والواي والزد، لأنه النقطة تقع ثلاثية أبعاد، إذا تقع في الإكس وفي الواي وفي الزد. فإذا كانت النقطة الأولى توصف ب x1 y1 z1، x1 بمعنى in I hat، y1 بمعنى in j hat، z1 بمعنى in k hat. That is the position factor. So R1 means the position factor، هي نقطة أو إحداثيات النقطة في الإحداثي القطبي، فتسمى R1 position factor for the point 1، R2 the position factor of the R2. How I can find it? How I can find this? Or how much this distance between or this displacement between the 2 points? It's very easy. So هي عبارة عن الفرق ما بين النقطتين. دلتا R عبارة عن R2 ناقص R1 the rate change between the 2 points. So R1 R2 is equal to x2 I hat, y2 j hat, z2 k hat, r1 equal to x1 I hat, y1 j hat, z1 k hat. So what is the delta r? Means delta r now it's equal to x2 minus x1, that is in I hat, plus y2 minus y1 in j hat, plus z2 minus z1 in k hat. So that is the position factor, or the displacement between these two factors in space. R is a position factor. الفرق ما بين النقطتين أو المسافة، الإزاحة ما بين النقطتين هي عبارة عن الفرق ما بين النقطة الأولى والنقطة الثانية، أو مع مقدار التغير ما بين النقطتين، وتكون كأصغر مسافة ممكنة ما بين هذه النقطتين. هذه أهم جزئية في هذه الشريحة. طيب الشريحة الثانية that is delta R. Delta R, as I mentioned before, x2 minus x1 in I hat, y2 minus y1 in j hat, and z2 minus z1 in k hat. So delta R means the delta x in I hat only, in x only, y only, and z only. So that is the displacement factor on the space. If this position factor R it's changing with the time as a function of the time, so that means the position, this equation for the position factor of position factor function with the time. How I can find it as a magnitude? Just only delta R absolute value is equal to the square root of delta x square plus delta y square plus delta z square. So that is the magnitude. القيمة العددية لطول الإزاحة ما بين النقطتين في ال 3 dimension هي عبارة عن الفرق delta R, the change of the position between the points with absolute value، القيمة المطلقة لمعدل التغير الإزاحة ما بين النقطتين، القيمة المطلقة تساوي الجذر التربيعي ل دلتا اكس تربيع زائد دلتا واي تربيع زائد دلتا زد تربيع. هذا يعطي الماجنتيود اللي هي القيمة العددية. وهناك خطأ دائما يقع في الطلاب. القيمة العددية delta R as a magnitude is equal to R2 minus R1, the rate change between the points R1 and R2. Sorry. Some students, they do look like this, and it is not correct. Delta R is equal to absolute value of R, position factor, minus the absolute value of the position factor of the factor 2. So that is not correct, it is wrong. Now we go through the quantities: the average velocity, the instantaneous velocity or V, same, the sample is same. So in chapter 2 we know the average velocity is equal to delta x divided by delta t. So that means the change between the final position and initial position. Here is same, just only replace x, that means in one dimension in x, in y in one dimension y, in z in one dimension z, change it with the factor, the sample that means in space. What is the mean of space for the displacement? It's r. So the average velocity is equal to delta r divided by delta t. What is the mean of delta r? That is the mean the rate change of position in I, j, and k. So v average means v average at I, that means in x, plus v average at j plus v average at k. So how you can find the magnitude? And the magnitude here, it is the speed. So the magnitude of the v average is equal to the square root of v average x square plus v average y square plus v average z square. And the average speed is the same, we can find it from the average velocity. So the average velocity is equal to the average speed, because we cannot find the speed because the speed is scalar quantities, and our things here we can discuss about the factor quantities, but with as a magnitude we can find the speed as scalar quantities by using the absolute value of the velocity as an average or instantaneous. Next slide, it's about the instantaneous, and we know also it can be found as dr, the first derivative, so now we start another part. It's about the v inst instantaneous. So in chapter 2 we know it, surah v is equal to delta x over delta t, and also we can find it from the, if I have an x of t function, we can find the velocity as the first derivative dx divided by dt. Same things I can do it, but just here in one dimension, in 3 dimension, so that replacement or change the x with r as a position factor. So v inst as a factor in space equal to delta r factor over delta t as a function with r of t function, so it's equal to dr divided by dt. How I can find the velocity? From it I can find the speed, so the absolute value v inst, it's equal to the square root of the v inst in x square plus v inst in y square plus v inst in z square as a magnitude. As a factor v inst, it's equal to v inst in I hat or in x plus v inst or v in y plus v inest in z. So that is as a factor, and here as a magnitude, and here from this point, it's a very important point, we can here find the speed, and I cannot find the speed if I am not finding the velocity. So the absolute value, القيمة المطلقة, as a magnitude for the velocity, it is the speed. The acceleration with the same steps. So here I know from chapter 2 the acceleration in chapter 2, it is delta v divided by delta t if there is a number. So if it's a function, so it is the first derivative of the velocity or the second derivative of the distance. So just only replace the dimension as one dimension with a position factor for 3 or 2 dimension. So in chapter 2, the acceleration average is equal to delta v divided by delta t. And here if it's constant, so I know that is the added, the final plus initial. The instantaneous in one dimension as a factor, as average it's equal to also the v final minus v initial divided by dt. So here v as a factor, just only put it and we can describe it and you can solve it in the space. So what I can do, just only change a average, it's equal to delta v as a factor divided by delta t. What's the mean of delta v? It means the v average in x, v average in y, v average in z, and that's it. For instantaneous, it is the same, or you can find it if it's a function of x of t, you can find it as a first derivative of the velocity divided by t. If from x direct, you can find the acceleration here, the acceleration from x of t, you can find the second derivative of x divided by dt squared. As a magnitude and as a factor, just only the absolute value of instantaneous and average in x and y and z. So that is the important thing in to describe the motion in space. We discussed about the equations, how you can use or how you can find the velocity and the acceleration and the displacement by using the kinematic equation in 3 dimension. So that is for the first part, and the second part I continue. Here there is an example. R here as a position factor, it given as function of t. So it's equal to 4t square I hat minus 5 tj hat plus 2k. So that means the object or the particle moves in 3 dimension, I, J, K. So number one, find the position at T. So if it's given the T, just only replace the time here. So T at, for example, 2 in the question. So 4 T is 2 square I hat minus 5 T 2 J hat plus 2K, there is no any T. Then R at 2, so it's equal to 4 multiply 4 I hat minus 5 multiply 2, 10 J hat plus 2K, so it's equal to 16 I hat minus 10 J hat plus 2K. So that is the position of the particle at 2 seconds. So now he needs the speed, and we mentioned before you cannot find the speed directly, you can find it from the velocity, because the speed is scalar quantities and here is a factor, so that means it moves in direction. So you can find it from the velocity, the magnitude of the velocity is equal to the speed. So then V is equal to dr divided by dt, the first derivative. So just I make a first derivative to this equation. To this equation, 4 is equal to 8t I hat minus 5j, there is no t, so it moves. So v at 1 second, so it's equal to 8 multiply 1 I hat minus 5j hat, so it's equal to 8 I hat minus 5j hat. So that is the velocity. Is the question finished? No, I need the speed. So what is the speed? The speed is the absolute value of the velocity, so it's equal to the square root of x squared plus y squared, because here just only moves into direction. So here I put the square root of 8 squared plus minus 5 squared, so it gives you what is the magnitude. Instantaneous acceleration, so it's easy because the velocity is already done. So A acceleration is equal to dv divided by dt. So here that is the v, so 8 I hat, so at any time it is the same number. So A at 1 second, it's equal to 8 I hat. So that is the important thing in this chapter. Next lecture, it's about how to use the kinematic equation to find also the acceleration and how you can calculate. So just I continue the second equation in few seconds, inshallah.